IPv6 review. As with all skill reviews, please listen to the question, pause, reflect on what you think the answer will be, then unpause to hear the discussion. Here we go. Number 1. In the transition to IPv6, we know that IPv4 uses octets and each one contains 8 bits. IPv6 will use blank and each contains blank bits. The answer is D. Hextet in 16 bits. Now, hextet, just for the books, is not the official name, as in no RFC standard has been created and said hextet will be what they call them. However, just through, I would say, organic convergence, for lack of better words, the industry has agreed that each one of them will be considered a hextet, which is not a real word until we just made that up. And every single one of those will contain 16 bits. That one is RFC standard based. Question number 2. When converting an IPv6 hextet to binary, which of the following is the correct conversion for 30B1? Well, first off, my approach, if you're looking for testing strategy, it's to go with the easiest one first. Remember, each one of these represents 4 individual bits. That's where we should get the 16 bits that's contained in each one of those hex sets we just discussed. So I would look at the 3 because I look at these answers and I'm like, okay, I know that is 2, 2, this one will be 4 plus 2, which will be 6. So immediately it eliminates all the other answers, which leads me to being C being the correct answer. But each one of these is treated independently. And I think the one that most people will struggle with is that B. Obviously, 1 is pretty simple down there where we've got our binary 1. Remember that in hexadecimal, where we have decimal numbers going 1 through 9, then we go 10, 11, 12, etc. In hexadecimal, we have 1 through 9, then A, B, C, etc., etc. So when we convert this, sometimes it's necessary to go with a decimal jump before we go back to hexadecimal. And we look right here, we go, okay, well, that'll be, what's that, 8, no 4s, 2, so that's 10, 11. So we might go, okay, that's an 11, which is a B, which allows us to line it up right there to the correct hexadecimal conversion. Question number 3. In the first rule of shortening the IPv6 address, you can do which of the following? All right, let's look at this. First off, you can drop the trailing zeros. No. You can't do that. If you have an IPv6 address, let's just say 1010:ABC0, right? You can't drop the trailing zeros. That actually changes the value that is represented in that hextet. You can replace the leading zeros with colons. No, that's also not the rule. You can drop the leading zeros. There's our answer. You can drop the leading zeros. So if you've got 00B1, right, colon, you can actually take those off. The rule of replacing the leading zeros with colons is actually not the leading zeros. You can replace subsequent sets of zeros, which will sometimes be written like that because we're using that first shortening rule. But we can take all of those and replace those with a double colon exactly once in there. That's the other shortening rule, right? But our first shortening rule is this one. Question number 4. Which of the following is not a type of IPv6 communication? Answer is C, broadcast. There is no broadcast in the IPv6 world. That's an IPv4 concept where we would send a message to 255.255.255.255, which would end up converting to the MAC address of all Fs, right? That's a broadcast message. And they said with IPv6, we're getting rid of that and replacing it completely with multicast. Ironically, they do have a multicast that says this message will reach all hosts on the local subnets, meaning it's exactly the same concept as a broadcast. We just use a multicast method to do it. So, question number 5. The EUI 64 will allow a host to assign itself an IPv6 address. Which of the following services is no longer needed in that case? The answer is B, DHCP services. DNS, forward lookups, this is a type of DNS request. definitely going to be something that's critical, especially with these massive names. You often call it IPAM, IP address management. That's just the concept of design of IP addressing, which is huge in the IPv6 world, just as it was in IPv4. There is a DHCP v6, so it's not like DHCP services is forced to go away. However, it's your choice if you want to use it. It's no longer a mandatory thing if you want to go with the type of dynamic addressing. And last question, question 6. Which command from the following will enable IPv6 routing? Well, you can feel the C theme in this review nugget. IPv6 unicast routing from global configuration mode will turn on IPv6 routing. Your router will work for IPv6, as in you can assign it IP addresses, you can do all the IPv6 configuration. However, it won't actually route traffic until you enable this one massive command. And that, my friends, is IPv6 core addressing concept. I hope this has been informative for you, and I'd like to thank you for viewing.